I am an avatar designed by Dr. Alemi to present this lecture. This is the lecture on regression. In this lecture, we focus on regression on one variable so we can explain some key concepts. The primary purpose of regression is to fit an equation to data that can be used to explain variation of the dependent variable as a function of the independent variable x. One of the most important functions of science is to describe a phenomena as a function of its causes. Regression is helpful in doing so. In regression, we fit data to a mathematical function. A function describes how a variable y depends on the value of other variables, referred as x. For every value of x, there is a corresponding value of y. If one is given a temperature in centigrade, represented by x, then the corresponding value in Fahrenheit, represented by y, can be calculated by a mathematical function. If the centigrade temperature is 10, the Fahrenheit temperature is calculated to be 32 plus 1.8 times 10, which is 50. Any equation of the form y is equal to a plus b times x is called a linear equation, because this is the equation of a straight line. I is referred to as the dependent variable. X is referred to as the independent variable. The constant a is the intercept, where the line intersects with the y-axis. The constant b is the slope of the line, the angle at which the line has with the horizontal x-axis. A straight line is defined by two terms, slope and intercept. The purpose of regression is to estimate the parameters of the equation so it fits best to the data. Regression selects the line with smallest sum of square residuals. The red lines here show residuals. A residual is the difference between the observed data and the predicted value on the line. Residuals can be positive or negative. The sum of residuals is 0. Regression fits a line to data that minimizes sum of the squared residuals. Let us look at an example. Suppose we predict students' grade from their SAT admission scores. The first step is to calculate deviation from the average y. Then square of these residuals. Calculate deviation from average of x. Square the deviation from the average of x. Next, calculate product of deviation from x and y. The angle of the line, the parameter b, can be calculated from the sum of the product of deviation from the average of x and the deviation from the average of y, divided by the square of the deviation from average x. The angle of the line can then be easily estimated. The intercept can be calculated as the average of y minus b, the angle of the line, times the average of x, yielding the estimate for the intercept. Then the equation of the line can be written as y equals 1.42 plus 2,000th of x, giving us an equation to predict students' GPA from their admission SAT scores. Thank you. This ends our lecture on how a regression estimates a line to fit the data.